Today we're trying to sketch out angle measures that are given in radians, and we will also try to find coterminal angles to ones that are given. We're also going to be looking at how to convert between radians and degrees. So we're taking what we did last time and just kind of building on that and using a different measurement. So kind of like going from meters to feet, we're going from degrees to radians. So we're still talking about angle measures, but I want you to get a little bit more comfortable with identifying where the terminal side of these angle measures are when they're given in radians. So let's get started here. Now what I'll do on this first one to kind of help us out is label these 4 key points here with 0. Oh, let's make that red. 0, and up here's 90 degrees, which is pi over 2 radians. Over here we've got pi radians. So it's 1 pi is 180 degrees, 1 pi radians. And then we got 3 pi over 2 down here. And then over here we got 2 pi. So when, oh, don't need a pi down there. Over here is 2 pi. What we're looking for is, where's this thing going to go? Where's the terminal side of pi over 4 radians? So on all these, in fact, what I'll do just to kind of get us going here is I'm going to include my initial side on every single one of these sketches, just so I don't have to keep drawing that over again, and I'm just going to copy and paste this. The beauty of Cami here. Why is it copying everything? I don't want it to copy everything. Okay, well, change of plans here. I'll do it on the second one so that when I select all this stuff, I don't have to worry about grabbing any other marks that I've made. So I just want to save a little bit of time here so I don't have to be careful about I want to be careful that I don't have to, worry about wasting time drawing all these. I'm just going to throw them all on there. So the initial side's always in the same place. So just bear with me here. So now I've got all my initial sides. Oh, okay. There we go. All my initial sides ready to go. And now I'm ready to start finding the terminal sides. Okay, so pi over 4 radians, you want to compare that to what we have here, 0, pi over 2, pi, 3 pi over 2. And what I normally think about it, I like to think about the fractions. Now I'm going to kind of go back and forth between the different ways to find out where the terminal side is. What I would want you to do is just sort of pick one, whatever you think is the easiest, and just kind of stick to that. So like on this one, I'm just going to say that, this is 1/4 pi at 1 over 4. And how does that compare to 0 or 1/2? Well, 1 over 4 is 1/4, and that is halfway between 0 and 1/2, right? So 1/4 is half of 1/2, so we know that it's going to be right here. In fact, without even doing the conversion, since it's halfway, we should assume that this is going to be equivalent to 45 degrees. And we can check that too. If you're ever not sure, and I'll use this method on the next one, if you're ever not sure where it should go, just plug in 180 for that pi, and then you can figure out exactly where the degree is. So you can see clearly that it is at 45 degrees, which makes sense because 1/4 is halfway between 0 and 1/2. So let's use this little method on the next one, okay? 3/4, we probably can figure out, where that's going to be, since this is 0, 1/2, and 1 times pi. 3/4 should be right here. Oh, you can't see my cursor here. It should be like right here. But let's just double check using this other method. So if I plug in 180, I've got 3 times 180. Oh, why is it not clicking? 3. Okay, well, let's close that out, open back up. I'm not sure why that's glitching out on me. Let's try again. Let's turn it on. Okay. So 3 times 180 divided by 4, and I can see it's 135 degrees. So if I know that 180 is over here and 90 is up here, 135 is halfway between there. So I do have my terminal side right here, and I need to make sure to include my rotation notation. It should look like this. 11 pi over 8. So now we're getting a little trickier here. So the first method, what I did was I just compared the fractions. I said, okay, 1/4 is between 1/2 and 0. Over on number 2, what I did was I just plugged in 180 and figured out where what the degree measure was. And so for number 3, I'm going to, first of all, let's move this calculator over. You don't need it. Oh, it'll go behind my face anyway. What I'm going to do is I'm going to look at this fraction and compare to, I'm going to look at this fraction. I'm going to find the decimal equivalent. So let's check that out. 11/8 is about 1.375. And I'm going to compare that to these key values over here. So, this is 0. This is pi over 2, which is like 0.5 pi. And here's 1 pi. And you normally would not write this, but just so we can get a better idea of where these should go, here's 1.5 pi and 2 pi. And so 1.375 would be in between 1 and 1.5. It's going to be a little closer, just a little bit closer to 1.5. So when I sketch it, I don't want it to be like right down the diagonal. I want to kind of curve it back over here a little bit. So here's where my terminal side will go, and there we go. Okay, so what I want to show you with these first 3 problems, at least, is I wanted you to see 3 different ways on how I can find where that terminal side is. So just to kind of recap that, I'm going to get rid of the calculator. We don't need that. You can either, look at the fractions if you're comfortable with fractions and see, where that fraction falls in between on these quadrants. Or you can just simply plug in 180 and find the degree equivalent, assuming you know where the degrees are. And then the third method was it's kind of like the first one where you're comparing the fractions, but if you just convert it to a decimal, sometimes that's easier. 11/8, you might not know exactly where that is. You can tell it's more than 1, but if it's not obvious that it's more than 1.5, you can type that in your calculator and get just a decimal equivalent there. So I think what I'm going to do is, I personally am comfortable with the fractions, okay? So if you're not comfortable with the fractions, choose one of these other methods, whatever is working, whatever works for you. But I'm going to stick with the fractions just because I think, for me, that's the easiest way to do it. I don't have to do any calculations or conversions or anything like that. I'm just going to, use my sense of size, as far as the fractions go, to determine where the terminal side should be. So number 4, negative pi over 6. Okay, so 1/6 is in between 0 and 1/2, and it's closer to 0 than 1/2, but it is negative, so I need to rotate in the clockwise direction. So negative pi over 6 should be right about here. Negative 5 pi over 6. So 5 over 6 is going to be pretty close to 1, right? Like, 6 over 6 would be 1. So 5 over 6 would be, pretty close to 1. So if negative 1 pi would be, let's try that again. If negative 1 pi would be right here, that would be negative pi, negative 1 pi, so negative 5 pi over 6 should be a little bit less than that. So I'm going to delete all that and draw my terminal side roughly right there and do my little rotation like this. For number 6, the fraction we're working with here is 20 over 17, and I'm scrolling down here, so I think it's good to have this, what I've written up here, number 1, as like a reference. So I'm going to actually write that down here so I can, just see it a little clearly. So 0, that's 1/2 pi is up at the top, pi, and then 3 pi over 2. So really, I'm sort of ignoring the pi because all of these values are in terms of pi. And so what I'm really just looking at is this fraction right here, this 20 over 17. So 20 is bigger than 17, but it's not bigger than twice 17. So I know it's at least bigger than 1. So it's definitely going to be, if here's my terminal side, here is 1/2, 1/2. It's definitely bigger than 1/2. It's bigger than 1. I guess the question is it bigger than 3/2, like 1.5? So 3/2 would mean that, what's half of 17? That'd be like 8 0.5. So if this was, let's see, what's 17 plus 8 would be 25. In order for it to be here, this would need to be, what did I just say, 25.5. So it's a little bit less than that. So we're going to put that down over here. And let's go ahead and draw our rotation. And there you go, okay? So 5 pi. So let's count pi's, okay? So if it's a whole number of pi's, it's starting to make me hungry. Let's just go ahead and count this out. So I'm going to rotate this. There's 1 pi, 2 pi, 3 pi, 4 pi, and 5 pi. So I am going to end up along the negative x-axis. And then when I go to draw my rotation notation, I'm going to do kind of the same thing. I'll just count pi's as I go. So here's 1 pi, 2 pi. Let me bring that in a little bit. There's 2 pi, 3 pi, 4 pi, and finally 5 pi. Now 1 radian, now we're getting a little tricky because notice this is not in terms of pi. So we need to figure out where that is. Okay, so now where's 1 pi? Now, or not even 1 pi, it's 1 radian. So I notice like a very common error is for kids to put it here and think, oh, 1 pi radian should go here. No, it's not 1 pi, it's just 1. So even though all of these are given in terms of pi, they do have a sort of numerical value. Pi is about 3.14, right? So if 1 pi is about 3.14 radians, half of that would be, let's pull up the calculator again and get a good number here. Half of pi, let's see what that would be. Pi over 2 is roughly 1.57, okay? So 1 radian is going to be less than this. Now, in the notes, we talked about what a radian was, and hopefully you kind of remember that it was, I think we said it was a little bit less than 60 degrees. So we're going to put it right here, and then our rotation should look like this. Number 9 is similar, where it's not in terms of pi, it's just 4 radians. So let's think of, so that would be more than 3.14, but what is 3 halves pi? 3 halves pi would be 4.7. Okay, so 4.71 is down here, and then we'd have 6.28 if you went all the way around. Okay, so this is approximately pi over 2. Over here we've got pi, 3 pi over 2, and the 2 pi. So for 4 radians, you can see it's going to be more than 3, but less than 4. And it looks like, it looks like it's going to be kind of roughly right in between. I'm not too concerned about exactly where it is. We just want to make sure it's roughly in the right place. We'll put it right here and say that our rotation goes like this. All right, so there's all the sketches. Let me just pull them up real quick so you can see them all together. Let's get rid of the calculator. Here's your screen grab. So if you want to just have them all at once, there you go. Let's now move on to finding coterminal angles. Zoomed in too much there. So here it says, give 2 angles that are coterminal to the given angle. So we're going to take the same approach that we did with when our angles were given in degrees, and we're going to add or subtract a revolution. We just need to make sure that we're using the units that are appropriate. So if this is in radians, instead of adding or subtracting 360, we're going to add or subtract 2 pi. So let's see. So what we're going to do to find the first one is we'll say pi over 6 plus 2 pi. And so to add, let me make that a little smaller so I can fit some more, just fit a little bit more in here. Is it going to be, it's going to be too small? Let's see. I want to make sure I can fit all my work in here. Probably easier to handwrite this, to be quite honest. Okay, so pi over 6 plus 2 pi is going to equal, well, let's just start a new one. Let's get rid of that. Is going to equal pi over 6 plus, and so we've got to find a common denominator here, which is going to be 6. So 2 can be rewritten as 12 pi over 6, or 2 pi can be rewritten as 12 pi over 6. So we've got 1 pi over 6 plus 12 pi over 6 equals 13 pi over 6. So this would be a coterminal angle that's positive, or it's an angle, a positive angle, coterminal to pi over 6. So I'm going to do that same thing. In fact, I'm just going to like copy and paste this because the work is going to be basically identical, except I'm going to subtract 2 pi instead. So pi over 6 minus 2 pi, so it will be the same thing as pi over 6 minus 12 pi over 6, which will be negative 11 pi over 6. And so here we have one positive and one negative angle measure that are coterminal to pi over 6. In other words, they have the same terminal side. Okay, so let's look at pi. This one will be a little bit easier to compute. In fact, my work on all these should basically be the same, except actually, you know what? On this one I'm not going to need that second step because I'm not going to have to find a common denominator. So this one will actually be a little bit easier than the last one, right? Because we're not dealing with a fraction. Why is it not? Oh, there we go. So no big deal. We've got, instead of pi over 6, we're dealing with pi. So let's go ahead and replace that. So we're going to do pi plus 2 pi, which we don't need any of that. It's just going to be 3 pi. And if I subtract 2 pi from pi, I get negative pi. So I don't need any of that work. I just get negative pi. And there's my solution there. I got a positive and a negative angle measure that are the same as pi. Now look up here, I actually have another one that I found 5 pi is in the same place as pi. So that could be another correct answer here. If I were to add 2 pi again to this, that's how I would get the 5 pi. So 3 pi over 2, let's go ahead and, oh, nope, I don't want that yet. I'm going to go ahead and copy my work over here. So we're going to take 3 pi over 2 and we're going to add or subtract 2 pi from that. So instead of pi over 6, we've got 3 pi over 2 plus 2 pi. So I need a common denominator there, and so 2 pi is the same as 4 pi over 2 because 4 divided by 2 is 2. So 3 plus 4 is 7, so I should get 7 pi over 2. So that is going to be an angle that's coterminal to 3 pi over 2. For this next one, I'm going to subtract 2 pi from 3 pi over 2, and so I've got 3 pi over 2 minus 4 pi over 2, so kind of very similar to what we did on the last one. 3 minus 4 is negative 1, so negative 1 pi over 2. And there you go. So we've got one positive, one negative angle measure that's coterminal of 3 pi over 2. So that's pretty much what we did on the first day, just in radians instead of degrees. You know, this homework looks almost identical, right? But now let's get into the conversion stuff. This is where we want to be able to go back and forth between radian measures and degree. So in this first one, I'm not sure why I ordered the questions like this, because really I think like 14 and 15 are going to be easier than 13. The strategy we will want to use if your radian is given in terms of pi is to replace that pi with 180. So we're going to do 3 times 180 divided by 2. You may or may not need a calculator here depending on your numerical fluency. You know, there's no shame in putting this in, but I think we can get away without it. 180 divided by 2 would be 90, and then 90 times 3 would be 270. So this should be 270 degrees. For number 15, this is where I'm kind of thinking we're probably going to need a calculator there. I just think the arithmetic is, that's just a little bit too much for my brain. 13 times, you know, in other words, like if you can reduce this like I did over here, 180 over 2 was 90, and times 3, that one's pretty easy. But 180 divided by 21, I think that can be reduced actually because they're both multiples of 3. I can see that. But I'm not going to, you know, try to do all that arithmetic mentally. If you want to, more power to you. I'm going to break out the calculator on this one. So let's see, we've got 13. I'm actually going to make the fraction here. Just just in case it ends up not being a whole number. But I think it will be because both, well, I don't know, is 21? Well, I guess we're about to find out, okay? No sense in pointless speculation. Okay, so we get this. That's kind of ugly, yeah? What is that as a decimal? Does it, well, it's a seventh, so it's not going to be a very pretty decimal. But just to get a kind of feel for it, here we go. And actually, going back and reading the directions, that's a bad habit of mine, reading the directions at the end, right? Round your answers to the nearest degree. So we do want to actually round this, okay? So we're going to actually say, and not equals, that's not the symbol we want to use here. We want to actually say it's approximately equals to. So we have this little squiggly equals, approximately equal to 111 degrees. One radian. Now here we can't do this little plug-in 180 trick. Okay, so we're going to have to use the same strategy that we're going to use for 16, 17, and 18, which is we're going to set up a proportion using a ratio that is known to find the unknown conversion. So just to kind of show you what your proportion should look like, it should be the, well, let's say it's pi radians over is the same as 180 degrees, and we want to set that equal to, well, either, so pi is radians, so we'll do radians divided by degrees, okay? And then we'll do some cross products property, and you know, check out the notes video if you want more detail on how that actually plays out. You're going to see it here in a second, but this is going to be kind of my go-to proportion. Here, let's make it kind of fancy here. This is going to be my go-to proportion. Yeah, I don't like the way that looks at all. Here, I'll do a little cloud bubble. Here we go. Make it look nice. That's the proportion we're going to use for these problems. So let's clear out this calculator. Let's get rid of that. So, although we may need the calculator eventually after we set this up. Let's go ahead and set this up. I'm going to just copy this so I don't have to retype it. And so so basically you can use this proportion every time, like whichever way you're trying to convert, and you're just going to replace the known with whatever it tells you is known, and replace the unknown with x, and then we'll solve. So here the radian is what's known, so I'm going to put a 1 there, and then my degree is the unknown, so I'm going to put x there, and now I'm going to use the cross products property to solve this. So I can say that x times pi is equal to 180 times 1. So I'm going to say pi x, let's go ahead and pi x equals 1 times 180, which is 180. And, you know, I don't know, do you need me to write 1 times? I don't think that's really necessary. Hopefully you can see what's going on there. And then what I want to do is I want to divide both sides by pi. So I'm going to divide that side by pi, I'm going to divide that side by pi, do a little handwritten work here. Or mouse written work, I guess. So I can divide both sides by pi, so I can cancel that out. And so if I'm trying to round to the nearest degree, I am going to need to put that in the calculator, 180 divided by pi. I don't expect you to do that by hand, since we're dealing with irrational numbers. I guess I need to pull the calculator back up and move it back out of the way. There we go. So 180 divided by pi is about 57 degrees. So not equals to, I'm going to catch myself there, approximately equal to 57 degrees. All right. Okay, so like I said, if it's not, you know, we saw a couple of sketches over here. Like, okay, let's go back to the actual graphs of these angle measures. One of the strategies that we talked about in terms of trying to find where the terminal side is to convert this to degrees and then figure out where that is, you know, if you're a little bit more comfortable with degrees. And so this is how you would convert 1 or 4. In fact, well, that's the same problem. It is 1. So yeah, we see it's 57 degrees roughly. 4 radians, we could kind of solve that the same way and figure out where that is. So just know that that's another strategy you could use. There's a couple different ways you could do that. All right, so let's convert from degrees to radians. We're going to do kind of the same thing here. We're going to use that proportion because we don't have a little trick like this plug-in 180 stuff. We don't have that for converting from degrees to radians. So let's start with number 16. And it says, give exact answers in terms of pi, no rounding. Okay, so that means that pi should be in our answer. All right, so we should get an answer like, like pi over 7 or something like that. So let's do number 16. So we're going to set up the proportion, and so I don't have to copy it. I'm going to actually take this, and I'm going to, well, I don't really need that squiggle around it. Let's go ahead and erase that. So I'm going to take this, and you know what I'm going to do? Since we're going to have to do this on every single problem here, is I'm going to copy this and paste it on all 3 of these. Whoa, that looks weird. All right, so here we go. Nope. Come on now, there we go. Okay, so here I know the degrees and I'm trying to find the radians. So my x is actually gonna be up here, and then my degree is 30 degrees. So I'm gonna use the cross products property, and so that will equal 30 times pi. Let's get that pi back in there. Oh, what happened to the pi? Weird. Okay, so 30 times pi equals 180 times x. And then we're going to divide both sides by 180. And we need to reduce that fraction. So let me show you how to reduce fractions in the calculator. 30, you might be able to do that, cross out the zeros and reduce 3 over 18. It's not that hard. But let's say it's like, a more difficult fraction to reduce, or you just want to check and make sure you're reducing correctly. Pull out the calculator, okay? And we're going to do, I'm going to do alpha y equals, and set up a fraction. I'm not going to include the pi because it's not going to be able to reduce correctly. So just ignore the pi temporarily, just while we're using the calculator, and do 30 over 180 just so we can figure out what that actually reduces to. So hit enter and it'll reduce to 1/6. So, I just temporarily forgot about the pi, but the pi is still there. So it's just 1 pi over 6, 1/6. Don't need to write the 1. And that is our answer. That is pi over 6 radians. In fact, let's go ahead and include the radians here. Wow, that is a big font. We don't need it that big. Let's just make it a little bit smaller. So pi over 6 radians. So these are equivalent. In other words, like if I were to sketch this angle measure in standard position, it would look exactly the same as this one. You wouldn't be able to tell the difference because they're the same. They're literally the same. It's like saying 12 inches instead of 1 foot. Okay, they're just 2 different units of measurements that's measuring the same thing. So number 17, we need to replace the degree with 540 and the radians with x, because that's what we're trying to find. We're trying to figure out what are the radians. We're going to cross multiply like we did in number 16. And so I should get 180 x equals 540 pi. Just like the last one, oh, wait a minute. I got an extra equal sign in there. Let's get rid of that. Now, just like the last one, we are going to divide both sides by 180 so that we can isolate that x. And so here we go. We're basically done, but we need to simplify, if we can, this 540 over 180. So I'm going to do like what I did in the last problem. Oh, nope. Did not grab the alpha button. There we go, alpha y equals. And we've got 540 over 180. 3. Okay, cool. So that's actually exactly 3 pi. Okay. Last one here, and then I guess we're done. So over here we've got negative 135 degrees, and we're looking for our radians. So we're going to make that x. We've got We're going to use the cross products property, just like in all the other ones. So we got negative 135 times pi. Oh, where'd my pi go? I just need a pi button on my keyboard. If anyone knows where I can find a keyboard with a pi button and maybe some other math symbols, that would be awesome. Let me know. 180x. That just gave me an idea. If that doesn't, it's got to exist. If it doesn't, that might be a good business opportunity. I might look into that, actually. That's not a bad idea. All right, I don't know why I wrote it backwards here. I don't really like that. I like the x on the other one. You know, this is what happens when I'm talking while I'm writing. Make all kinds of errors. I got the wheels turning about that math keyboard. So I'm going to divide both sides by 180. And so I get x equals, you know, I didn't put x equals here. I think it's okay. Well, let's just go ahead and throw it in there. Clean it up a little bit. So x equals, let's go ahead and reduce that fraction. Negative, I'll keep the negative. You know, as long as you know it's going to be negative, you know, if you forget to type it in the calculator, not a big deal, because we're really just using this as a tool to help us reduce. So just make sure your final answer is negative. So negative 3/4. Okay, so we got negative 3 pi over 4. And that's it for today, y'all. Okay. You know, as always, if you have any questions, let me know. Shoot me an email. You know, or hey, you could even throw in a comment in the comment section below, and I will answer it for sure. Let me get this box looking good. Other than that, y'all have a great day, and I'll see you guys next time.